Good morning to all. So today we are going to learn circuit analysis. So our unit 1 is basic circuit analysis and network topology. So we have these topics: Ohm's law, Kirchhoff's law, mesh, current and node voltage method of analysis for DC and AC circuits, then network terminologies, graph of a network, incidence and reduced incidence matrix, trees, cut set, fundamental cut set matrix, tie sets, link current and tie set schedule, twig voltage and cut set schedule, duality and dual networks. So we will be seeing about all these topics one by one. So before entering into the topics, we should learn about some basic terminologies so that it will be easy for you to understand. So the first thing is charge. So charge is the basic quality in an electric circuit. So all matters are made up of atoms, and these atoms consist of electrons, protons and neutrons. We know electrons are negatively charged, protons are positively charged and neutrons are neutral charged. So this is the definition of charge. Charge is the electrical property of the atomic particle present in the matter. So it is the electrical property of the proton or electron or neutron. So the unit of charge is coulomb and the symbol of charge is represented as Q. Next comes current. Current, it is defined as the rate of flow of electrons in a conductive or semiconductive material. We know current flows only through a conductor or a semiconductor. So current is nothing but the flow of electrons. We know electron is negatively charged. So the flow of negatively charged electrons is called current. So it is represented as I. The unit of current is amps. Then we have two types of current, AC current as well as DC current. AC means it will be varying sinusoidally. We can see here, this is a AC signal. So here comes the voltage and here comes the time. So when time changes, the value of the voltage will change. So at this point, if you check the voltage, it will show one value. At this point, if you check the voltage, it will show another value. Like that, it will be constantly varying all over. So it is called as alternating current. The next one is DC. Here the magnitude will be always constant. So this is the DC current. So here comes the time and here comes the voltage. So at whatever time you can check, the voltage will always remains the same. Then the next one is voltage. Voltage means the potential difference between 2 points in electric circuit is called voltage. So it is represented as V. The unit of voltage is volt. The next one is power. Power is the rate at which work is done. So power is represented as P. The unit of power is watts. So power is usually represented as the multiplication of power can be represented as P is equal to V into I, voltage into current. It can be also represented as I square into R, and it can be also represented as V square by R. So we know Ohm's law, V equal to I into R. When you are applying I into R, you will get I square R. Instead of this I, if you are applying V by R, you will get V square by R. So that's all about power. Then network, interconnection of two or more circuit elements, that is called as a network. So here you can see you have a voltage source, you have a resistor. So some elements are connected together. So this is called a electrical network. Then circuit. A network contains, then circuit. If a network contains a closed path, then that is called a electric circuit. So this is a network. In this network, if you are closing this, it will be a circuit. Then branch. A part of a network which connects various points of the network with one another is called a branch. So we can see here you have a voltage source, resistor, all these things. So this resistor is connecting points A and B. This resistor is connecting point B and C. So we will call this as a branch, this as a branch, this as a branch. So AB, BC, BE, CF, EF, DE, everything are branches. Next, junction point, a point at which 3 or more branches meet is called a junction point. So you can check this network. So here a point at which 3 or more branches meet. So 1, 2, 3, 3 branches meet at this point. So that is a junction. So B is a junction. Similarly, this branch, this branch, this branch, these 3 meet at this point. So that is another junction point. So B and E are junction points. Next one, node. A point at which 2 or more elements meet is called a node. So we can take this as a node A. So this voltage source and this resistor meet at this point. This point, this branch and this branch, everything meet at this point. So that is a node. C, this resistance and this resistance meet at this point. So that is a node. So like that, if 2 or more elements meet, then that is called a node. Next, loop. Loop is any closed path of branches. So we know AB is a branch, BE is a branch, ED is a branch, and DA is a branch. So this, it forms a closed path. That is a loop. Similarly, B, C, F, E, B. This one forms a closed path. That is another loop. Then A, B, C, F, E, D, A. Everything forms a closed path. So that is another loop. Next one, we have mesh. A mesh is a loop that does not contain another loop. All meshes are loop, but all loops are not meshes. So here we have seen this is a loop, this is a loop, and the whole thing is another loop. Mesh means a mesh should not contain another loop. So this is a mesh and this is a mesh. You should not take the entire thing. You can see here, a mesh is a loop that does not contain another loop. Only this and this forms a mesh. Now we can see the classification of electrical network. So electrical networks are classified into 8 important groups: active network, passive network, unilateral network, bilateral, linear, non-linear, lumped and distributed. So active means they are the energy sources. We know voltage source and current source, both are the active sources. Passive element, so they store energy or dissipates energy in the form of heat. So active element will supply, passive element will dissipate it. So resistor, inductor, capacitor, so these elements will receive voltage or current from the source and it will dissipate in the form of heat in the case of a resistor, or it will store the charge in the case of inductor as well as capacitor. Then unilateral element, if the voltage current relation is not same for both the direction, then that is called a unilateral element. Diode and transistor are the example. You know the graph of a diode. So during forward bias it will be traveling linearly, but during reverse bias only after breakdown it will start to conduct. So both sides of the graph are not the same. So such an element is called unilateral element. Bilateral element, voltage current relation is same in both the direction. Example, resistor. You know a resistor, you can place the resistor in any direction, it will resist the flow of current. Next, linear element. If the element obeys superposition principle, then they are called linear elements. Resistor, inductor, capacitor are the examples. Then non-linear element. If the given network is not obeying superposition principle, then it is called a non-linear element. Example, transistor, diode. Then lumped element. Physically separable elements are called lumped elements. So in a circuit we will have resistor, inductor, capacitor. If you want to remove it, we can easily separate it. Such elements are called lumped elements. Distributed elements. It is an element which is not separable for electrical purpose. We know transmission line. You will have a pole here and you will have a pole here. Wires will be flowing. Wires will be connected in between. So in those wires, it will have resistance inductance, capacitance, everything. You can't remove that. So such elements are called distributed elements. Next we will see what is a short circuit. So if a circuit element is replaced by ideal good conductor, then it is said to be a short circuited. So here you can see this circuit. So A, B, C, D. So you have a resistor here, you have a load here. So if you are removing this load and you are replacing it with a good conductor, such a circuit is called short circuit. So in a short circuit, voltage is minimum and current will be maximum, because it is a low resistive path. So current will flow through this. So current will be maximum and voltage will be minimum. Next, open circuit. In a circuit, if any component is removed, then the removed terminals are said to be open circuit. You can see this circuit. So here you have a resistor and you have a load resistance. You are just removing this. So it will be left to open. So here voltage is maximum and current is minimum. So it is a open circuit. No current flows through this. So current will be minimum and voltage will be maximum. Then voltage source in series. So suppose we have 3 voltage sources in series, V1, V2, V3. You can see here plus minus, minus plus, plus minus. So the equivalent of this voltage source can be found like this. We can come from the top. So first we are entering plus. So V1 is positive. Coming here it is negative. So V2 is minus. Coming here V3 is plus. So it is positive. So V1 minus V2 plus V3. That is the equivalent of this network. So when voltage sources are in series, you can easily add it. Current sources in parallel. So when number of current sources are in parallel, you can replace it like this. So you can see here I1, I2, I3. 3 currents are there. I1 current is flowing upwards, I2 current is flowing up, I3 current is flowing down. So everything is connected to a same node. So you can draw it like this. So I1 and I2 both are in the forward direction or in the top direction. So you can put plus I1 plus I2. This one is flowing in the opposite direction. So minus I1 plus I2 minus I3. So current sources in series will have same current. Voltage sources in parallel will have same voltage. So here voltage sources, if they are in series, you can add. If voltage sources are in parallel, they will be same. Similarly, if current sources are in parallel, you can add it. If current sources are in series, the current will be same. Next we will see resistors in series. So here you can see a voltage source. You have 2 resistors R1 and R2. So if 2 resistors are said to be in series, then the equivalent resistance will be the sum of individual resistances. So you have a voltage source, negative, positive. So current is a flow of electrons. So from negative to positive, the charge will flow. So it will be flowing here. The same current will be flowing through this. The same current will be flowing through this. So these two will be said to be in series because same current flows through these 2 elements. So in this case, the equivalent of this can be written as R equivalent equal to R1 plus R2. Next we will see resistors in parallel. So here you can see 2 resistors are connected in parallel. Suppose if you are supplying a current through this current will come here. It will be splitting into 2. One will be flowing here and another will be flowing here. What is flowing here will flow through R1 and what is flowing through this will flow across R2. Both will be getting united here and it will go out. So you have supplied current here, you have divided here, and one portion of this current have flown here and another portion of this current is flowing here. So different current flows through resistors R1 and R2. So these two are said to be in parallel. So in this case, the equivalent is given by 1 by R equivalent equal to 1 by R1 plus 1 by R2. So that is equal to, you can take the LCM. So R2 plus R1 divided by R1 plus R2. Sorry. You can take the LCM. So R2, R1, denominator you will have R1, R2. So this is 1 by R equivalent. You can invert it. So R equivalent equal to R1 R2 divided by R1 plus R2. Next one, inductors in series. So two inductors are said to be in series when same current flows through them. The same what you have seen for resistor is applicable for an inductor. So L equal to L1 plus L2. Similarly, inductors in parallel. The same what you have seen for resistor will be applicable for inductors also. 1 by L equal to 1 by L1 plus 1 by L2. You can take the LCM and you can invert it and you will get L equal to what? Next, we will see capacitors in series. So two capacitors are in series. If two capacitors are in series, the equivalent capacitance is given by sum of reciprocal of the individual capacitance. So 1 by C equal to 1 by C1 plus 1 by C2. You can take the LCM and you can find this. So in the case of inductor and resistor, if two inductors and two resistors are in series, you can simply add it. But in case of a capacitor, you want to perform this. Then capacitor is in parallel. If two capacitors are in parallel, you want to add it. So it is just the inverse of what you have seen for resistor and inductor. Hope you have understood till this. We will meet again in the next class. Thank you.